Okay, so part 2, we're going to do some more examples. I'm going to show you the long way and reinforce that heavy sides cover up. Okay, so let's see if we can be a little quicker about this. So again, if I try a traditional u-substitution on this, if I let u equal, again, it's a quotient, can't be simplified, let u equal the denominator, I have x's. For my du, I don't have anything to work with that, so I'm going to factor. So pause, please, factor, and come back. Okay, so I have 2 over x plus 4 times x minus 1, all right, and I'm going to break this up into linear factored denominators, essentially writing it as the sum of its parts. Okay, so I'm going to have a over x plus 4, or I'm sorry, the integral of a over x plus 4 plus b over x minus 1 dx. I want to figure out what a and b are, so I'm going to go through the process of finding the common denominator. Okay, and some students think of this almost like they're cross-multiplying. I can cross-multiply this way, and I get the same thing, but I think of it as what's missing from this denominator to get over here. I'm missing an x minus 1, so I've got to multiply top and bottom by x minus 1. What's missing from this denominator is the x plus 4, so I can multiply top and bottom by x plus 4, but I'm just focusing on the numerator. So try it and think about what the numerator has to equal. Pause it and come back to me when you've got it. So we should have come up with a times x minus 1 plus b times x plus 4 has to give me 2. Okay, and then what I said before is that we should skip steps here. If I distribute through, I'd have an a times an x plus a b times an x, and I'm going to factor out my x, so I'd have a times an x plus a b times an x, factor out the x. Okay, and then my constant term is going to be, I have an a times a negative 1, that's going to give me a negative a, and then I have a b times a 4, that's going to give me a 4b. Alright, and then I have to get my 2 on this side. So let me clean that up a little bit. So like I said, we have a plus b times x plus 4, oh, I screwed that up, didn't I? Okay, better. I'll have a plus b times x plus negative a plus 4b, and that has to equal my numerator, which is 2. Okay, and now I get to match things up. So this a plus b here has to match the x term on the right side, but there is no x term. So think about what a plus b has to be. And then I have my negative a plus 4b, that's my constant term. It has to match my constant term over here. So write me a system of equations with a and b in it. Pause it and come back to me. Okay, so we should have that a plus b, the coefficient on x, has to match the coefficient on x. Because there is no x, the coefficient on x is 0, so a plus b has to equal 0. And then the constant term, negative a plus 4b, has to match the constant term, which is 2. And so here's my system. Okay, I would again say elimination would be the easiest technique on this, but you can also do substitution. Either way, solve for a and b, pause the video, and come back to me, please. Okay, so like I said, I thought elimination was easiest. If I add these straight up and down, I get that 5b equals 2, divide both sides by 5, and I get that b is 2/5. Okay, and then if a plus b is 0, that is going to make a equal to negative 2/5. Okay, so now that we have a and b, we can rewrite our integral. So all that algebra just to rewrite an integral. Okay, so we have the integral of negative 2/5 over x plus 4 plus 2/5 over x minus 1, and I'm going to integrate this now. So go ahead and u-sub it if you need to see it. Otherwise, make sure you're getting correct answers, but pause the video, integrate, and come back to me. Okay, so if I do u-subs on u equaling x plus 4, my du is just a dx, and I have an integral of 1 over u du. So I get natural log absolute value u, no change in coefficient. Same thing for the second piece. If I let u equal x minus 1, du is dx. I have the integral of 1 over u du, which is natural log absolute value u, which is why there's no change in coefficients on either of these. I just get my negative 2/5 as coefficient, natural log absolute value of x plus 4, plus 2/5 times natural log of absolute value of x minus 1, plus c. Okay, let's look at this using heavy sides cover up. Okay, so let's look at this again with heavy sides and just reestablish what heavy sides does. Okay, so I'm going to start with each linear factor, and I'm going to set each piece equal to 0. Okay, so x plus 4 is equal to 0 when x equals negative 4. If you think that you've mastered it from the first slide, pause me and try it on your own, and then come back to me when you think you've got it. Otherwise, watch again. So I'm going to set the linear factors equal to 0. Okay, so this equals 0 at x equals negative 4, and then I literally cover that up, that linear factor up. Okay, and then I plug in this negative 4 into whatever's left here, and I would get 2 over negative 5. Okay, and that's going to go up in here, 2 over negative 5, or negative 2/5. Okay, now we're going to do the other side. So we're going to look at where this linear factor is 0, and that's happening at x equals 1, okay, and then we literally cover up that term, okay, and we plug in 1 to whatever's remaining, and if I plug in 1 here, I'm going to get 2 over 5, and that's what I put up over there. Okay, so the Heavisides cover-up just allows me to get through the algebra faster, okay, and lets me integrate faster. Our answer would be the same answer that we got before. Okay, the integration would go the same way, okay, and that's that. Okay, I want you guys to try this one on your own. The integral of x minus 9 over x squared plus 3x minus 10 dx. I want you to integrate it both, or to do the partial fraction decomposition both the long way and with Heavisides cover-up so that you know that you're able to do both possibilities, and just so that you can verify the answer that you should come up with in the end is this. So try to work it out, make sure you get this answer, and I want you to make sure that you're able to do it both ways. Okay, so this is the last example we're going to do, the integral of x squared plus 2x minus 1 over x cubed minus x, okay? It's still that rational function form, it's a quotient, it cannot be simplified. If you try a simple u-sub, you're not going to get anywhere with this one. Okay, so I'm going to start the same way by factoring the denominator, so go ahead and pause it and factor, come back. And I'm doing this in stages, but I could factor an x out of that denominator, and then I can factor it completely. Okay, so what's different about this one? I have 3 linear factors, okay? It's not going to really change much. I'm going to have 3 pieces to my puzzle this time instead of 2. Okay, so I've got my 3 linear factors here, and I'm going to need to figure out what a, b, and c are, okay? And I know that I spoke about cross-multiplying with, I have 2 linear factors, we can't really cross-multiply when there's 3 of them, but if I want to get from this denominator to this denominator, what do I have to multiply that numerator by? Well, top and bottom, I have to multiply by the x plus 1, x minus 1, so I'm going to be doing a times x plus 1. I'm going to just write it sloppy, and then I'll clean it up for you guys in a minute, okay? And then for the second piece, okay, I have an x plus 1. What's missing? I'm missing the x and the x minus 1. Okay, and then for the c part, I have an x minus 1, but I'm missing the x and the x plus 1, so I'm going to do c times x plus 1. All right, and this is going to have to equal my numerator from up here. So let me clean that up for you guys. Okay, a little lengthier this time, but I have what I have written there. Okay, so I have my a times my x plus 1, x minus 1, my b times my x and my x minus 1, and my c times my x and my x plus 1. All right, so now I'm going to be, well, first of all, I need to kind of evaluate what's going on in here, okay? And if you think about what's here, I have an x squared term, an x term, and a constant term. I'm going to have to figure out what those parts are going to be, what those coefficients are going to be. So let's simplify these first 3 things that I underlined. So go ahead and pause and simplify those and come back to me. Okay, and a little FOIL, a little distribution. I've got a times x squared minus 1 plus b times x squared minus x plus c times x squared plus x equals x squared plus 2x minus 1. All right, now I'm going to have to match up my coefficients. So I've got an a times an x squared, a b times an x squared, and a c times an x squared. I'm going to add those up, ax squared plus bx squared plus cx squared, and then factor out the x squared. And that'll give me a plus b plus c times x squared. I'm going to write it sloppy first, and then I'll clean it up. Okay. I've got terms that have plain old x's in it. I've got a b times a negative x. That'd be a negative bx. Factor out the x. I've got negative b. And then I've got a c times an x. That's going to be a positive c times an x. Factor out the x. I'd have that as my coefficient on my x term. Okay, and then the only constant term I have is going to be right here, a times a negative 1, which is going to give me a negative a. All right, so match those up with the coefficients on x squared, the coefficient on x, and the constant term on the right. Pause and come back to me. Okay, so this is what I just wrote, except without all the sloppiness. And then if you match them up, you should have come up with the following 3 equations. Okay, so I have a plus b plus c equals 1, negative b plus c equals 2. Now the a plus b plus c matches the coefficient on x squared, and the coefficient on x squared over here is just a 1. The negative b plus c matches the coefficient on x. The coefficient on x is a positive 2, and the constant term is my negative a is going to match my value of negative 1. Okay, let's start with the simplest one. I can solve for a very quickly here, and I would get that a is 1. Okay, if I take that 1 and I put it in back up here, if I have 1 plus b plus c equals 1, then that means b plus c equals 0. So, and I took that second equation, negative b plus c equals 2, and if I combine these, I can do it with simple elimination. I got that 2c equals 2, or c equals 1. Okay, and if I go back up here, and I have that b plus c equals 0, if c is 1, that's going to make b equal to negative 1. Okay, so now that we have our three values, we can put them back in an integral. So go ahead and put those values back in your integral, and then when you go ahead and integrate it, and you can pause it and come back to me when you're done. Okay, so here's my integral, the integral of 1 over x minus 1 over x plus 1, plus 1 over x minus 1. And each of these requires, well, the first one is a straight up integration, but the other two require simple u-subs. I do not get a change in coefficient, so if you're showing me them, great. If you're not showing me them, that's fine too. And I'm going to end up with, and here's our lovely answer, natural log of absolute value of x minus natural log of absolute value of x plus 1 plus the natural log of absolute value of x minus 1 plus c. Okay, I do just want to quickly mention that I could have done all of this stuff in here using Heaviside's cover-up. It does work, and I will show you very quickly. Okay, so with Heavisides, I take each linear piece, I set it equal to 0, so I take the first one, it's equal to 0 when x equals 0, and then I cover it up. And then I plug 0 into what's left, and in the numerator I'm going to get a negative 1, and the denominator I'm going to get a negative 1, so I get a 1 up here. Alright, next piece, x plus 1 equals 0 when x equals negative 1. Okay, now I cover it up, and I plug negative 1 in for what's left, so that's going to give me negative 2 over positive 2, which is going to give me a negative 1. Alright, last piece, x minus 1 equals 0 when x equals 1. Okay, now I'm going to cover it up. Okay, and I'm going to plug in 1 into what's left, so that's going to give me 2 over 2, which is 1. Okay, so I can still do Heavisides on this. I'm going to get the same constants in my numerator that I did the other way, and then I can just go ahead and integrate this the same way that I integrated it before, and I should get the exact same answer. Alright, that is it for us. Partial fraction decomposition does get more complicated, but it does not show up any more complicated on the AP exam, so this is as far as we're going to take it.